morning, algebra people. Change it up. Okay. So today we're starting something different. So we're going back to absolute values. So I just want you to remember here, watch and see if you recall this. Absolute value always has to be positive or 0 or greater. And we always had two equations for this. Remember, I drew these arrows. So you would say b plus 3 is equal to 2, but also b plus 3 is equal to negative 2. And then you would solve it twice and get your two answers. We did this a few weeks ago. So we would solve this one and get b equals negative 1. But also, when we minus 3 here, we would say also b could equal negative 5 because both of these answers work in that equation. Okay? Okay. This one, again, you would write two equations. 4 minus 2n equals 8, and 4 minus 2n equals negative 8. And then you would solve it twice, minus 4, and we would get negative 2n equals 4 on this side. The great thing about this right now, we didn't have to think about flipping the sign. This was prior to that. So we had n equals negative 2, but there was also another answer for these where you would have negative 2n equals negative 12, dividing by negative 2, and would also, it's not negative. No. It would give you a positive 6. So you would have those two answers that would also work, again, in this equation. And then we have these kinds. The big snafu was, remember, I told you here, do not distribute that. The first thing you had to do was divide both sides by 8. And then you got your equation that was an absolute value that you would then say equals 4 and there's a 4 here, equals negative 4, okay? So first you have to get rid of everything outside of that absolute value, and then you would solve. So I know you could keep going. So this should be a reminder from a few weeks ago before we had all of those inequalities. So now today we're going to put that together, the absolute values and the inequalities. So here's what I want you to do. I want you to think, and my hint to you would be, I'm going to go ahead, okay, and just basically here, take a look at that, okay. Okay, now, could we figure out from this which one's which? I'll give you a hint. Look at this versus this, okay? Because today what we're doing is doing absolute value inequalities, an inequality equation, but it's actually with an inequality symbol. So remember what those things I just highlighted, this kind of a statement, anytime you see this sign, it's an and. Think about that. And then we go back to those compound ones. This is an or. So let's call this number 3. Number 3, what would it be? It's an and. Okay. Number 4 is going this way. It's an or. Okay. Number 5 is going this way. This is irrelevant. That's just filled in or not. That's an and. And the last one is also a and. Do you see that? So again, we're going to be putting these together today. So again, when you see this sign, whether it has this or not, it represents an and. If you see this sign, whether it has this or not, it's an or. You might want to write that down. Okay, so look here, and we're still going to write two equations like we did. Okay, so we have y plus 2 is greater than 8. It's exactly like that. And now I look, do you see this? Is an and then we say y plus 2 is greater than, and the same thing we did before, negative 8, okay? And then you're just going to solve minusing 2 from both sides. You have y is less than 6 and minusing 2, y is greater than negative 10. Okay, so now take this, what we just did, and again, we're off. It's going to be too much difference. So if I say this is negative 10, they're just too far away, and 6. So y is less than 6. So it's at 6 going less than, and y is greater than negative 10 and going this way. Do you see where they meet? It's a tweener. So that's your graph, but I want you to rewrite that just like this, and my solution actually looks like this. Watch, 10, negative 10, eats that way, x eats that way, 6. This is actually my solution. Down here is still the work, but my final answer needs to be written as a tweener for those that graph as a tweener, even though it's an and. Okay, let's see this one. Okay, so again, q divided by 3 is greater than 2. This symbol means it's an or, so it's not going to be one of those tweeners. Q divided by 3 is less than negative 2. Make sure that's a negative. Okay, so I'm going to show my work. So we have q is greater than 6, or q is less than negative 6. Now it's an or, so we don't need to combine them like we do for an and. So say we have a negative 6 here and a positive 6 here, they're just far away. They kind of are written backwards. So look here, q is greater than 6. So that's what that means. And now that one, q is less than negative 6, and that should look familiar. That's really what those ors looks like. So again, there's your solution, and your graph of it is up at the top. Okay, let's do a couple more. Same general concept. Okay, so we have y minus 3 is less than or equal to 4. And when it's a less than, I know it's an and. Y minus 3 is greater than or equal to a negative 4. Okay, so I'm going to add 3, and it's an and. So you have to make note of that. So y is less than or equal to 7. And again, I'm going to add 3. Y is greater than or equal to negative 1. So I have a negative 1 here and a positive 7 there. Okay. So now it's y is less than or equal to 7. So filled in going less. Y is greater than or equal to negative 1. Filled in going greater. Yes, it is a tweener. So that is my graph, but my solution needs to be rewritten. They are both filled in circles. The smaller number goes there. The bigger number goes there. Okay. So the blue one is my solution for an and for the most part. Okay, we're going to keep going. Again, f plus 12 is greater than negative 4. And I look, greater than is an or. F plus 12 is less than positive 4. I got to do the opposite. Okay, so I'm going to minus 12 from both sides. So I get f is greater than negative 16. I'm bringing the word or down. Minus 12. F is less than negative 8. Okay, it's an or. So you're good to go. So now I have negative 16 here and a negative 8 here. Remember, the smaller number just needs to go to the right or to the left. The bigger number goes to the right, Mrs. Struggler. Okay, so let's do the 16 one. 16, okay, and it's greater than negative 8, and it's less than. Oh, because this is an or, it's either or, so I want the entire thing shaded. If it's an and, it's only a betweener. But if this happens for an or, it's actually the entire thing, because at some point, all of those numbers are going to be shaded. Remember, it's either these or those. It doesn't matter. It's all of it. So the actual answer is one of your favorite things. Infinite solutions, all real numbers. It's the entire number line. That's a tricky one. That's a tricky one. Pay attention. You might want to go back and look at that one. Okay, here we go again. So we have x over 4 minus 7 is less than negative 2. A less than is an and. X over 4 minus 7 is greater than positive 2. Okay, now let's think about that. Okay, can a number ever be an absolute value less than a negative? Because this is going to end up funny. I just started thinking about this, and you go, can an absolute value, can I ever have a number here giving an answer that is actually smaller or less than negative 2? No. Nope, that doesn't make any sense. And let me prove it to you. If I add 7, I get x over 4 is less than 5. Multiplying, by 4, I get x is less than 20. And so that means it's where they overlap. Adding 7, x over 4 is greater than 9. And when I multiply by 4, x is greater than 36. So let's think about that. If this is 20 and this is 36 and it's an and, okay, if I have a number going this way for the 20 and this way for the 36, do they ever overlap? No. So it doesn't make any sense. Same thing I was saying up here. This up here can't ever be smaller than negative 2. So this is actually a big old no solution, because an and means an overlap. There is no overlap here. Be careful. Okay, and just one more just to make sure you're on track. So again, negative 1n, remember I like to write that number in there, plus 9 is greater than 1. That's an or. And then I have negative 1n plus 9 is less than negative 1. Hint, hint, you might want to reference this when you're talking about doing your homework today. Minus 9 from both sides. So I have negative 1n is greater than negative 8. Then I'm going to divide by negative, and same rules apply. I must flip that sign. N is actually less than 8. And it's still an or, so I'm going to minus 9 again. Okay, so I have a negative 1n is less than negative 10. When I divide by negative 1, I got to flip the sign, so n is greater than 10. Okay, it's an or, so I have 7, 8, 9, 10, 11. So it means both of them. So 8 hollow circle off to the left because it's a less than, and 10 going off to the right. Reason why I highlighted that one, you still have to flip the sign when you multiply or divide by a negative. Okay, here you go. Another little sample. That last problem we just did was on your worksheet, so take your time. And tomorrow we'll come back and do more of it. So if you're struggling, try your best and come back tomorrow. We will do more. Okay, have a great day.